Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog. We're going to do some more with related rates here. I really like putting this problem out there for my students. Sand is being poured onto a conical pile at a rate of 10 cubic feet per second. If the radius of the pile is 2/3 of the height of the pile, at what rate is the height of the pile changing when the height is 30 feet? And then after we're done with that, I'm going to ask at what rate is the radius of the pile changing? So first of all, this is a related rates question because it says cubic feet per second. Now, ladies and gentlemen, cubic feet, that's a volume, so I need the volume of a cone. The volume of a cone is 1/3 pi r squared h. And here's why I like this problem. Number one, this has two variables. Number two, and when I say two variables other than v, two variables on the same side of the equation. And this is a product rule. So if I wanted to actually take the derivative of that function, the derivative of v with respect to time, I would have to take the derivative of this first part, which would be 2/3 pi times r to the first times dr dt, and I'd have to multiply that by h. Then I'd have to add that 1/3 pi r squared times the derivative of h, which would be dh dt. This equation literally has 5 variables. It's got h, r, dh dt, dr dt, dv dt. This is ugly. So what I've told my students, wouldn't it be easier if I could figure out a way to write this original equation just in terms of r or just in terms of h? Now, if you read the question, it is asking, what is the rate of change in the height? So it makes sense that I want to put everything in terms of h. Okay? Well, how do I put everything in terms of h? Well, number one, it says the radius of the pile, which is r. The word is means equals. 2/3 of is multiplication times the height of the pile, which is h. So r is 2/3 h. And what I can do is I can put that into my formula. It's 1/3 pi. R is 2/3 h, and that would be squared times h. Now, I still don't want to take the derivative of this just yet. Why don't I want to take the derivative of this? Because this is still a product rule. Volume would be 4 squared, or 2 squared is 4. 3 times 3 squared is 27. I've got pi. And h squared times h, this would be h cubed. So there's the 2 squared, which is 4. 3 squared times that 3 is 27. And then, of course, I've got h squared times h. This is where I got my equation. Now, it is going to be much simpler to take the derivative of that function. The derivative of v with respect to time, that's easy. Do a power rule. Bring that 3 out front, I'd get 12. 12 over 27 reduces to 4/9 pi times h squared times dh dt. A much simpler derivative formula to use here. dv dt, while I'm adding 10 cubic feet per second onto the pile, dv dt is positive 10 cubic feet per second. I'll write that on here. dv dt was positive 10 cubic feet per second. So I plugged it in. What's the height? Well, the height, it says, was 30 feet. So I'm going to plug that in. And I need to find dh dt. So to solve this for dh dt, I would have to, first of all, multiply by 9. That would give me 90. Divide by 4 pi. 30 squared is 900. You'll notice I'm not really multiplying or dividing everything out because I'm going to try and simplify some of this, just not using my calculator. Sometimes you may end up with teachers who don't let you use a calculator. 90 goes into 900 10 times. The answer here is 1 over 40 pi. And what would be my units? Well, h would be measured in feet. Time here is measured in, and I'm going to have to scroll back up and look, it's measured in seconds. This is my answer for the rate of change in the height of that pile. It's changing 1 over 40 pi feet per second. Now, the second part of my problem, I want to find at what rate is the radius changing. Well, what most people would think is why not take this equation, solve it for h equals 3/2 times r, and plug that into this formula and go through this whole process again. You can do that. You can absolutely do that. That's correct. But why don't I use this original equation, this r equals 2/3 h? Why don't I take the derivative of that? What's the derivative of r with respect to time? It's dr dt. This would equal 2/3 times the derivative of h with respect to time, which is dh dt. But I already know what dh dt is. It's 1 over 40 pi. So this is going to reduce to 1 over 60 pi feet per second. That's the rate of change in the radius. You'll notice I can take any equation that I have in the problem, and I can take the derivative and use it to help me solve this problem. Now, I really hope I have enough time to do this next problem. A 13-foot ladder is placed against the wall and the base starts sliding away. By the time the base is 5 feet from the house, the base is moving at a rate of 36 feet per second. At what rate is the height of the top of the ladder moving? Now, we already know in the picture that up and down is y, left and right is x, and the ladder is 13. So I'm thinking I'm just going to write my equation for part A. I'm going to write x squared plus y squared equals 13 squared. The ladder is not changing length, but x is changing and y is changing. Well, let's take the derivative. The derivative here would be 2x times dx dt, dx dt, plus 2y dy dt, and that equals the derivative of 13 squared would be 0. And at this step, I'm also going to divide by the 2's. I don't need those anymore. This side I divide by 2, it would be gone anyway. Now, what's x? It says the base is 5 feet from the wall, so x is 5. It says the base is moving at 36 feet per second. It's positive 36 feet per second because x is getting bigger. What's y? Well, y, this is where I can do the Pythagorean theorem off to the right. I can do x squared, which is 5 squared plus y squared equals 13 squared. This would give me y squared equals 13 squared minus 5 squared is 144. Y is 12. So 12 here plus dy dt, this would equal 0. So in order to solve this, dy dt would be 5 times 36 would be subtracted to the other side, and I would divide by 12. This comes out to be negative 15. Y would be measured in feet. The time would be measured in seconds. That top of the ladder is flying down the wall at 15 feet per second. That thing is moving. Now, part B says, how do I find the rate of change in the area of that triangle that's formed by the ladder and the ground and the wall? Well, the area of that would be 1/2 x times y. This is part B. It's 1/2 the base, which is x, times the height, which is y. Well, let's take the derivative of this. The derivative of this would be dA dt. That's the rate of change in the area. And I'm going to have to do a product rule. The derivative of 1/2 x would be 1/2 dx dt times y plus 1/2 x times dy dt. Well, guess what, ladies and gentlemen? I know all those variables. It's 1/2 dx dt we said was 36. Y we found to be 12. Then I've got 1/2 times x, which is 5, times dy dt, which I found to be negative 15. Now I'm taking out my calculator and I'm multiplying this out for you guys, and I come up with 178.5. Well, what are my units? Well, area here would be measured in square units, so square feet. And time, we already know, is measured in seconds. So at this point, at this moment in time, the area is actually increasing on that triangle 178.5 square feet per second. And you might be thinking, well, that triangle's not going to exist anymore when the ladder hits the ground. That's true eventually, the area will decrease again. But for now, this area is increasing when it is 5 feet from the base of the wall and 12 feet from the top of the 12 feet, the top of the ladder is from the ground. Now I've got one more problem I want to do here, and this is part C. It says, at what rate is the angle between the ladder and the ground changing? Well, ladies and gentlemen, I know everything here. I know that this is y, this is x, and this is 13. I can pick any trig function that I want. I'm going to pick cosine. Cosine of theta is the adjacent over the hypotenuse, x over 13. Now, I could have used sine. Sine of theta is y over 13. If you'd like me to do that, I could. There's no way you're getting me to use tangent of theta. Tangent of theta is y over x. I'd have to do a quotient rule. I don't want to do that. But it's just as easy to take the derivative of cosine, which is negative sine of theta times d theta dt. The derivative of x would be dx dt, and that would be multiplied by 1/13 or divided by 13. So what is sine of theta? Now remember, we know that x is 5. We know y is 12 from the previous question. So sine of theta would be 12 over 13. dx dt, we know that from the previous problem is 36. This would give me 36 divided by 13. And to solve for d theta dt, wouldn't I take that 36 over 13 and multiply by negative 13 over 12? And this reduces to negative 3. You notice I haven't touched a calculator for this cosine problem. I did use it for part B, but I could get away with not using it. This is negative 3, so the angle is actually decreasing, which makes sense. And this would be angle is measured in radians, time is measured in seconds, so that angle is decreasing 3 radians per second at that moment in time. It's not always 3 radians per second. It is when that base is 5 feet from the wall and the top of the ladder is 12 feet from the ground. I hope you liked this video. I hope these videos have been helping you with your related rates. If you like, please hit the like button and subscribe. I'll be posting more videos later.